Good morning, everyone. Welcome to the fifth lesson, for acid and bases. Also the last part before I conclude with acid and bases, and then for the next one, I'll start with salts. All right. Let's take a look at the very last part. So there's two things that you need to learn. One is on oxides. Which is quite a big part of it, because oxide alone, as you can see, you need to learn the reactions. You need to know the examples, as well as you need to know the solubility of the oxide. Alright, so there's three things to learn regarding the oxides. Then after which these are reactions. You got another thing, which is liming. So that means what do you do to tackle the problem of acidic soil? So now let us look at oxides first. So there's four types of oxides. So the first level of classification is to see whether it's a metal or a non-metal. Alright. So basic oxides, they are basically the metal oxide. So most of the time I try to remember the exception, then the rest under the metals and the non-metals respectively. Let's look at the four types. I like to call them Barna. Basic, A, amphoteric, neutral, and then acidic again. Alright, Barna, basic, amphoteric, neutral, acidic. So for the metal oxide, most of it fall under basic oxides. They are also bases. Remember bases is oxides or hydroxides. That's what we discussed earlier on. If you look back at what's a base. Over here. Where is it? Bases they are metal oxides or hydroxides. So examples wise, you have copper 2 oxide, iron 2 oxide, magnesium oxide as well. A lot of examples. I actually can't list all of them. Alright. A lot. So most of the time just remember the amphoteric one, then the rest are all basics oxide. Amphoteric one, you have ZAL, zinc oxide, aluminium oxide, lead oxide. If you use the chemical symbol is ZAP. So sometimes I like to call it the Z oxide, zinc oxide, aluminium oxide, and lead oxide. So in terms of reactions wise, basic oxides are bases. So we react with acid. Acid plus base gives you salt and water. But the amphoteric one, there's a typo. I want to change this part to react with both acid and bases. Important. Please change. So the key thing here is both acids and bases. With an acid is a base. So I add on down here to elaborate a bit. With an acid, it acts as a base. Then when it's with a base, it acts as an acid. Alright, then in terms of solubility wise, basically basic oxide, most of them are insoluble except for group 1, B and C. Group 1, this is group 1. Group 1, barium and calcium oxide dissolve in water to form alkaline. So remember, alkaline are soluble oxides. They are soluble bases, right? Amphoteric ones, they are basically insoluble in water. Then we move to the other side, on the non-metal oxides one. For the acidic oxide, it reacts with base to form salt and water. But I don't remember acidic. Actually, I remember the neutral oxide as monoxides. So example, you have all the monoxides are carbon monoxide, nitrogen monoxide, water. Sometimes I call them the no go water. Okay, hopefully it helps you to remember better. Okay, and they are insoluble in water. Okay, so the rest of the non-metal oxide, which they can be a variety lah. Can be dioxide, trioxide, okay, or even weird things like P2O5, also considered acidic oxide. Okay, so you have a lot of them sulfur trioxide also. Okay, SO3. This is sulfur trioxide. Okay, this thing exists Okay. So a lot of examples. So long as it's not monoxide Okay, if it's a non-metal monoxide, it's a neutral oxide. Okay, that means no reaction. Examples are the no cold water, insoluble in water. Okay, acidic oxide, most of the time they are soluble in water to form acid Alright. Okay, for example, you dissolve sulfur dioxide in water, you get sulfurous acid Okay, so this thing is actually your sulfurous acid. Right? Okay, and then they react with base to form salt and water. So later on I'll give you examples to illustrate the reactions. Okay, just on the next page. Okay, so let's look at the basic oxides, which I think you're quite familiar because they are bases. Okay, example is copper 2 oxide. Okay, plus hydrochloric acid gives you, I have a very bad typo. Okay, copper 2 chloride and water. Alright, okay, so copper 2 oxide is Cu2 plus. Okay, oxide is group 16, O2 minus. Then acid is H plus, and then chloride Cl minus. Okay, copper 2 chloride, copper 2 again so that means the charge of copper is 2 plus, chloride is minus so this one you got to do crisscross. Okay, then once formula form, you realize there's 2 chloride on the right, so you need 2H plus, 2Cl minus. Okay, to balance it off. Okay, next thing I have acidic oxide. Okay, acidic oxide, I think something you're more familiar with if you recall the test for carbon dioxide. Carbon dioxide is actually an acidic oxide It's a non-metal dioxide. If you recall, let me scroll back the reaction between carbon dioxide and calcium hydroxide, which is your lime water Okay, this thing is your lime water if you recall back on page 9 Okay, it gives you calcium carbonate and water. So this one is like the salt It's like an acid and alkaline kind of reaction. Alright, okay, so now I go back Okay, so this case I have sulfur dioxide with sodium hydroxide to give you sodium sulfide and water. Okay, I think something you're more familiar with when you did your lime water test is this This one is the white precipitate Okay, and then you have water. Sulfide is SO3 2 minus alright. Then sodium is Na plus. The formula is Na2SO3. Alright. Okay. Next thing is your amphoteric oxide. I think I decide to use zinc oxide as an example. Okay, it can act as an acid or a base depending on who is with. Okay, with an acid, it acts as a base. Okay, acid itself is quite easy to see because got the name acids. Okay, zinc oxide with sodium hydroxide, then it acts as a acid. Okay, so hydrochloric acid H plus Cl minus. Zinc is 2 plus, not in group 2 but always 2 plus. Okay, if you look at the periodic table, zinc is in group 12 but always 2 plus yeah. Okay, okay, going back. Okay, then you have zinc chloride again. Zn is 2 plus, chloride group 17, Cl minus. Alright, so balance the 2 chloride. You need 2 sets. Alright, okay. Then you have even weird one. This one you don't really have to know. The zincate is the very weird one. The ZnO2 2 minus. Okay, that's the zincate Okay, very weird one Okay, this one I just show you I think more importantly, what you have to know is that when it's with alkaline, it act as an acid lah. Alright, okay, that's a more important. And of course, neutral oxide best lah. Insoluble in water, no reaction, nothing to learn ah. Okay. Then the final part of acids and bases is the application of lime. Okay, so what do I mean by lime? Lime is actually a family of calcium compounds. Okay, whenever I say lime, okay, so you have slaked lime, which is calcium hydroxide, quick lime, which is calcium oxide. Okay, so slaked lime, okay, or even quick lime can be used in increasing the pH of acidic soil. Okay, so basically what it does is that it reacts acid in the soil to form salt and water. Okay, or otherwise, even better term to use is in neutralize the acid. Okay, so this allows farmers to achieve optimum pH for maximum crop yield, because different crops grow at different pH lah. Okay, they got their optimum one. Like sometimes potato you need a bit acidic soil. Okay, sometimes cabbages you need a bit more alkaline soil. Alright, okay, so later on I think there's an example lah, we can have a look at that. Okay, so before that, let's take a look at the part on the oxides. Okay, so for this you have to see whether it's metal non-metal. Okay, so this one is a non-metal dioxide. So if you look at this, okay, non-metal dioxide, they are actually acidic oxides. Okay, and manganese is a metal. Okay, then it's not the Z, right? Not zinc, aluminium, or lead. P is the chemical symbol for lead lah. If you like the name, then it's ZAL lah, not potassium lah. Okay, so this one is basic. Okay, amphoteric, you have one of those in ZAP, aluminium. So that's amphoteric. Okay, and once again, carbon dioxide, non-metal dioxide. So that one is acidic. Okay, alright. Okay, so acidic one, basically they must be non-metal, and then they cannot be monoxide lah. The rest all can actually. Okay, neutral ones, they are non-metal, and then they are monoxide. Okay, not a lot of them lah. Usual examples, the wait. The no cold water. Okay, even water is a monoxide, dihydrogen monoxide. Okay, amphoteric ones, then they must be your metal oxide. Okay, in a sense, those three are ZAP, zinc, aluminium, lead. The rest of the metal, okay, is under basic. That's how you see it. Okay, this one is your ZAP, lead. Chemical symbol for lead is PbO. Okay, lead 2 oxide. Okay, carbon monoxide, yes. Okay, non-metal monoxide, so neutral. Then this one is your ZAP again. Phosphorus, non-metal. Okay, this thing I think is P2O5, non-metal. And then not monoxide. So it's acidic. Okay, alright, moving on. Okay, using only substances from the list below answers the questions that follow. Okay, acid found in lemon. This one is your citrus fruit. So you got citric acid. Okay, it's actually a weak acid. Alright, but we seldom deal with it. Insoluble base. Okay, base is soluble if it's in group 1, barium or calcium. Okay, and what's a base? Base is actually an oxide or hydroxide. I mean metal oxide or hydroxide. Okay, so copper 2 oxide. The rest cannot, I think. Yeah, don't have. Sodium hydroxide is alkaline. Acidic oxide, you have to pick a non-metal one. Okay, but cannot be monoxide. Okay, not monoxide. So that means something like this cannot. Carbon monoxide cannot. Okay, so silicon dioxide or otherwise nitrogen dioxide lah. Okay, two substances that react to give a sulfate salt and water. Okay, remember sulfate salt actually you need sulfuric acid. Okay, so that one cannot go in. Okay, then after that acid plus base gives you salt and water. Okay, so base is metal oxide or hydroxide. Okay, so you can have copper 2 oxide, aluminium oxide. Aluminium oxide is amphoteric lah, but your function okay. Otherwise, sodium hydroxide also can. Another possibility is sodium hydroxide. It's an alkaline, also can. Okay, then substance that react with acid and base. This one is amphoteric lah. Some of my students last time, okay, don't quote me okay, they what you call that? They remember it as bisexual. This one, okay, I don't know why. Okay, oxide that undergoes any reactions does not undergo any reaction. Okay, so this one is neutral. Neutral means must be non-metal monoxide. Okay. Then next one for aluminium gas. Okay, then this one you need a case of ammonium salt. Triple ASW. Ammonium salt plus alkaline, not acid. Gives you ammonia gas, salt and water. Okay, ammonia gas is NH3. Not to be confused with ammonium. Ammonium is NH4 plus. Alright. Okay. So alkaline is this one lah, sodium hydroxide. Okay, alkaline is a soluble base. Okay, which usually comes from group 1, barium or calcium. Okay, most bases are insoluble except for these few, they are soluble. Okay, and then the very last question before we end acids and bases is that a farmer wants to grow peas, okay, in the field. So a farmer tests the soil and find it has a pH of 6. Okay, so this quite acidic. So but peas need slightly acidic soil. Okay, that means you need the pH to be more than 7. So what do we do? So not suitable because at pH 6 soil is slightly acidic, not suitable for peas which require slightly alkaline soil. So something that you can add is either calcium hydroxide or calcium oxide. So you do a liming. Okay, this one is your quick lime. This one is your slick lime. Okay. You cannot use other kind of hydroxide because they are insoluble. Okay, so explain in terms of chemistry involve the effect this chemical has on the soil. Okay, is that calcium hydroxide being a base will react with the acid. Okay, so after the acid is neutralized, pH of the soil will increase slightly. Alright, so you're using a base to neutralize the acid lah. Okay, so what's happening here is so it's a acid plus base reaction to give you salt plus water. Alright, so after farmer has treated his soil, is now suitable for growing peas. Okay, so maybe a pH around 8 like that lah. Okay, slightly alkaline. Okay, and if you recall the colors of the universal indicator, which I usually like to use Roy G beef lah. Okay, maybe we can indicate in the previous section. Okay, Roy G beef down here. Okay, colors of the rainbow. Okay, let's have a look. Okay, so red is 0 to 2, orange 3 to 4, yellow 5 to 6, green is blue is 8 to 9. This one is 10 to 11, indigo around there. Violet usually for strong alkaline, 12 to 14. Okay, so this is blue. Okay, so next one. Okay, very interesting question. How come because ammonium sulfate ammonium salts usually are used as fertilizer. So immediately after that, the farmer go and add calcium hydroxide. Very hardworking. After you add fertilizer, you do liming. So in terms of explain in terms of chemistry why what will happen if you allow them to mix? It's not advisable. Okay, reason is this. Okay, so let's say you are growing crops. Okay, under the hot sun. Okay, you are the farmer. Okay, you add ammonium sulfate. Then after that you add calcium hydroxide. There's a reaction happening, Okay, why? Because it's a ammonium salt plus alkaline reaction. Okay, we just talked about it just now. Now is the application side. Okay, you get ammonia gas plus salt plus water. So the important thing about this is this. Okay, ammonium salt inside ammonium is like that. Let's say ammonium sulfate Okay, you got a lot of nitrogen. Okay, but once this reaction happen, you get ammonia gas which will escape into the surrounding. Okay, so the nitrogen is gone. So what's the point of adding a fertilizer? You add the fertilizer is because you want the nitrogen. But now you add in the slaked lime, it will actually react with your ammonium sulfate to produce ammonia gas. Then your nitrogen content is all gone because it escaped in the form of the ammonia gas. So that defeats the point. So what you do is this your ammonium sulfate you have to mention will react with calcium hydroxide to form ammonia, calcium sulfate and water. Okay, so then the nitrogen content in the fertilizer will be lost when ammonia escapes in the air. So this is something that you shouldn't be doing. Alright, okay. Alright, then I think that's the end for this part.